So we've previously looked at different types of sequences. Arithmetic, that's the one where you keep adding something over and over. And geometric, that's the one where you keep multiplying over and over. So now we're going to sort of make this into a formula. And the formula is written right here to help us find an arbitrary term in the sequence. So we basically just need to know a couple of things. We need to know what the first term of the sequence is, and we need to know the common difference. So if it's an arithmetic sequence, we need to know those two things. Then we can write this formula and we can find anything we want. The reason is because we are going to know how many times we are adding that thing. So if you know how many times you're adding something, that's just like a multiplication. So for example, we have an arithmetic sequence with the first term 4 and a common difference of 10. What is the fifth term? Okay, so that's pretty small. So we can just kind of do this by writing the sequence. So we start with 4, and then we add 10, so we get 14. We add 10, so we get 24. Now we're at the third term. The next term is 34, and the fifth term would be 44. Okay, so let's think about that. To get from the first term to the fifth term, we had to add 10 1, 2, 3, 4 times. So one less than the number term that it is. We did the fifth term, so we added 10 4 times. That's where this n minus 1 comes into our formula. The n minus 1 represents how many times you need to multiply by d, which is your common difference. That's how the formula, that's how we get the formula. So now let's take a look at using it. To find the 100th term, it would sure be a hassle to write out 100 terms. But based on this formula, I know that doing the 100th term is the same thing as adding 10 99 times. So I just need to add 10 99 times, or another way to say that is I'm going to multiply by 99. So for example, if I'm going to use this formula where I have a sub n, so the nth term is equal to, according to my formula, it's going to be the first term. A is the first term, so 4 plus then n minus 1. So in this case, that's going to be 100 minus 1, or 99, like I said, times the common difference, which is d. The common difference in the formula is here. So that's going to be 99 times 10. So now we can evaluate this. It's actually pretty simple. 4 plus 99 times 10. 99 times 10 is 990. So the overall answer for the 100th term is 994. So if I use this formula, it's actually easy to find, even if it's a pretty far off term that I'm looking for. I just subtract 1 from the term that I'm looking for. If I'm looking for the 50th term, I multiply by 49. If I'm looking for the 817th term, I would multiply by 816 times the common difference and then add the starting. And we can actually do something like this, similar with geometric. So let's take a look at the geometric formula. This is similar, although because it's geometric, because it involves multiplying over and over again, it's going to get either bigger or smaller very quickly. It's going to tend to do that. But you'll notice this formula is very much the same. The only difference is it's the exponent that's going to be n minus 1, not something you multiply by, but the exponent, so dictating how many times you multiply that ratio by. So again, let's start with a very simple example. Looking for the third term, then we'll apply it further and look for the 15th term. So let me give myself a little bit of a space here. All right, we have an arithmetic sequence, first term 3, and a common, actually, this should say common ratio. We say common ratio when it comes to a geometric sequence, not a common difference. Um, so a quick correction here. Geometric sequence with a first term of 3 and a common ratio of 2. The third term then would simply be, so I start with 3. So I start with 3, and then the common ratio is 2, so the next term is going to be 6. And the third term is going to be 6 times 2, which is 12. So notice that here I multiplied by 2 and I multiplied by 2 again. How many times did I multiply by 2? N minus 1 times. So it's going to be, again, a to the n is equal to a, the starting thing, times r to the number of the term minus 1. So now let's look at the 15th term. This number is going to get very big, but we can use a calculator, okay? So let's go ahead and a, and this one way of the notation is say a sub 15. That means the 15th term. That's simply going to be 3. Okay, remember the first term is 3 times 2 to the power of 15 minus 1 to the 14th power. I don't expect you to know what 2 to the 14th power is off the top of your head. I don't know what it is off the top of my head, but we can just use a calculator real quickly. So I went ahead and plugged that into the calculator. 2 to the 14th power is 16,384. So all that remains is to multiply that 16,384, which again, 2 to the 14th power, I solved with a calculator, and multiply it now by 3. So therefore, the 15th term is going to be 3 times 16,384, which is going to be equal to 49,152. Again, you can just go ahead and use your calculator to do this. So this is basically what you're going to be doing for the homework. I'm going to do a couple more examples here, which are almost exactly like what you're going to see for the homework. Okay, so you'll notice in these examples below, I tell you if it's an arithmetic or a geometric, the first term, and then either the common difference or the common ratio. So for number 1, the first term is 17. So I'm looking for the 300th term. So according to the formula, and if I were to go back up, I can look at the formula at the top here. It's going to be basically the initial thing plus n minus 1 times the common difference. Okay, so let's do that. So the initial thing here is going to be 17 plus n minus 1. So the n is the number of the term, so that's 300 minus 1, or 299 times 8. And again, at this point, you can crack open your calculator. You do 8 times 299, and then you would add 17, because in order of operations, you want to do your multiplication before you do the adding. And when I do the math there, the final answer is 2,409. So if that's 299 times 8, and then to that, I simply add the initial 17. So that's how the formula works. Remember the 299 here. The 299 here is simply one less than this, because one less than the number of term you're looking for is the number of times you need to multiply. Okay, now let's see. Moving onward, I'll do one more example with a geometric sequence. The geometric formula, again, I can look it up here. It's going to be the initial term of the sequence times the common ratio raised to the power of n minus 1. Common ratio raised to the power of n minus 1, and that gets multiplied by the first term in the sequence. Okay. So the common ratio here is 3. The common ratio here is going to be 3. And how many times am I multiplying 3? Well, it's going to be 3 is going to be raised to the power of 12 minus 1, which of course is going to be 11. And then I have to multiply that by my first term. So it starts at 5, and then I multiply it by 3 a bunch of times. How many times specifically? Well, it's 1 less than 12, or 11 times. So I can rewrite this as 5 times 3 to the 11th power. And of course, now, because of my order of operations, I want to do the 3 to the 11th power first. Again, I don't know what that is off the top of my head. I do not expect you to know that, but I do expect you to be able to put it in a calculator. So we're going to do 5 times at whatever number 3 to the 11th power is. So it turns out that 3 to the 11th power is going to be equal to, it's going to be equal to 177,147. Then my job is to simply multiply that by 5. So that's going to be equal to 885,735. So again, I took my starting number and I multiply it by 3 a bunch of times. How many times do I multiply it by 3? Or in other words, what's the exponent? It's going to be the number of the term I'm looking for minus 1. And that's how you do it. Hopefully this helps. Thank you.